Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is, I think, video 4 of my data structures video series. And this video is going to be about array and linked lists. So I'm going to talk about what like sort of a native array is, and what we're going to build out is what we're going to end up building is a linked list. Okay? Because all an array is, so if you ever program in C, like arrays are just things that they exist. So what you have to imagine is that, let's say you have your memory, and let's just pretend like every block of memory is like the exact same size. Let's just keep a lot of the finer details separate, okay? So let's just say that one block can hold a number. Okay, and that's one sort of unit of memory. So essentially what happens is that generally in programming languages like C or Java or Go, what you do is you specify the size of your array when you create it. So you say, hey, I want to create an array that holds numbers. Okay, and I want it to hold 5 numbers. So essentially what's going on under the hood is that you go into the memory, you find a blank chunk of memory, and you say, okay, well, we're going to start here. This is where the array starts. And I want 5 spots, so I'm going to create 5 spots. And then I'm going to add one more spot. And this 5th spot really is just kind of like, all it really is just like an indicator that this is the end of the array. So I can put in my numbers. So I'll say, hey, this one's 5, this one's 6, and I want to store 3 over here, 2 there, 1 there. Okay. Okay, so the problem is, well, let's just, now the good thing about like a traditional true array is that all these pieces of data are literally sequenced right next to each other in memory. So the time that it takes, and this may seem like nanoseconds, milliseconds, the time it gets from to say, hey, I want to look at, and again, this is index 0, 1, 2, 3, 4, and then again, I'm assuming you have some prior knowledge of working with arrays in any programming language. So index 0, so if I say, hey, I want to go find, the data in index 3, literally is just once the computer gets to where the first spot, because essentially really what an array is, like when you put the array in a variable, it's really just a pointer. It's pointing to the first spot. So when I say, hey, can you take me to array, index 2, it's really just say, hey, 0 is the starting spot, and then plus 2, it takes me there. Plus 3, it takes me there. So it's just really like this spot in memory plus the index. Okay? So when I say, hey, take me to index 4, I start at 0. So basically the pointer to the first spot in memory plus 0 is this, because plus 0. This is why 0-based indexing. And if I say the first spot of the array plus 4, 1, 2, 3, 4, I get there. Okay, and then there's no more array left. So that's sort of like I'm pretty sure what's the reasoning why like indexes start at 0. Because technically what's going on under the hood, it's the array itself is just pointing to the first spot, and then the index is being added to that initial spot. So technically the start plus 1 is the second spot. Now the problem with the traditional array is like this is fast because again they're all sequentially right next to each other, so there's not a lot of movement that has to go on physically within the memory. But I can't add anymore because there might be a chance that something else got added in the next sequence of memory because other stuff happened, and now I want to add stuff to this array, but I never allocated more space. So if you ever worked with one of these lower level languages where arrays work this way, it's really annoying because if you want to add something to the array, you have to go create a new array with an additional spot, copy everything over, add the new thing, and then you have your new array. Which, sometimes you may have a function that does that, sometimes you don't, but that's a lot of work just to add one item to an array. Okay, so that's what an array is. So a true array is really just basically a sequential chunk of memory where you have certain blocks that hold a particular like data type. So in this case I'm saying hold numbers, and the array, the variable array, is really just a pointer, meaning it's just pointing to where that first block is, and the index is just saying like how removed are you from that initial block. So I'm one away from the initial block, etc. And then you run into errors when you push further. Because if I say, hey, go to index 5, it's saying 0 plus 5. I hit here, and there's no data here. And that's when I start getting errors. I'm outside of the bounds of the array. There was nothing put there. Okay, and that's when you start getting into errors. Okay, cool. So that's an array. But what if I still need to have like a lot of data, but I want it where I can more easily like add a thing to the data? And this is where like linked lists come in. Okay, it's still not technically the way you see like arrays done in let's say like JavaScript, Python, and Ruby. Like the way I understand it there is that they're actually using a class under the hood, and technically like each of the essentially what's happening is that you're creating sort of like key value pairs for the array items where the number is the key. So it's more like it's essentially like a hash map class thing at the end of the day. I'd have to like read more into the implementation, but that's why like when you use arrays in like Python, Ruby, and like JavaScript, they're so flexible. Like it just seems like you could just throw as much as you want in an array. It's magic, okay? But because what actually is going on isn't a true array under the hood. It's like all this magical class stuff, okay? Because I think most of those languages were originally created in C++, which is really just C with classes. Cool. So now let's talk about, so what if I did this instead? Okay, we'll say, hey, here, and instead of using a bunch of sequential pieces of memory, we're just using different pieces of memory from all over the place. Okay? And then we don't need this anymore. Okay? So essentially, a linked list means we don't care where the memory actually is. Again, you point to the first spot. That's like really what the variable is pointing to, is pointing to where the first block is. And then what happens is that this piece of data is really like two pieces of data. So basically what it is, let me just go over here, add that there. Really what's going to happen now is that each piece of data is really going to be 2 blocks. 2 blocks of memory, because we need to hold an additional piece of data. We need to hold a pointer. So essentially here, really, it's always like the data and then a pointer that points to the next piece of data. So again, let me just illustrate this. Pointer. A pointer. And again, a pointer is just a variable that points to a specific spot in the computer's memory. That's what a pointer is. It's just saying, it's not saying we have the number 1, it's just saying where the number 1 is located in the computer's memory. So basically this would be the first number, and then this pointer would point to the next piece of data, and then this pointer would then point to the next piece of data, and then this pointer would point to the next piece of data, and then this pointer would point to the next piece of data, and then this pointer would necessarily point nowhere. This is a singly linked list, okay? So essentially there's always like really 2 pieces of data that are in each node, okay? So the node is just not the data. The node contains a second piece of data, which is the pointer to the next thing. What is the next node? Okay, and then eventually there is no pointer, okay? Now we can make this like I think it's called like a circular round list, or I forget the exact term. But what would happen is that a circular linked list, let me just see if I can look that up. Circular linked list. I know what it is. Yeah, so it's just the same thing. It's just basically what's going to happen here is that the last item then points back to the first item. So essentially, if you are in the latter half, because again, the whole issue is traversal. How quickly can I get to, how many jumps do I have to make to get to the data I want? So for example, if I'm currently here, 1, 2, 1, 2, this would be the way. But let's say I'm here, like for some reason I'm currently here, because that's the piece of data I'm using now. If it's a circularly linked list, I can more quickly get to this first number because I can instead go forwards, go boop, boop, instead of having to go bop, bop, bop. So there are benefits, but the thing is, and then I'm also having to use this additional piece of memory to hold the pointer back to the first one. Okay? And the problem is I can't even go backwards right now. So because this is a singly linked list, so I can only move forwards. Because I only got a pointer to the next one. I have no pointer going back. So what I could do is I could add a pointer going back. Let's get rid of these arrows. Okay, I could do that. And this would be called a doubly linked list. Because the linked list not only has a pointer to the one ahead, but also to the one going before. But again, now I'm using up more memory. So now I have more flexibility in deciding sort of which is the best way for me to go. So basically what you're seeing now is a circular, doubly linked list. It's circular because the very last pointer points back to the beginning, but it's doubly linked because also now this pointer will point back to here, and then this will point back to here, and then this pointer will point back to here. And let me just fix this over here. This should be there. And then this pointer will point back to here. And then just again fix it again here. And then again, it being circular, the first one, the previous pointer would then point all the way back to the last item. Okay, so you see like the data is scattered all across my memory. They're not a sequential block, but it's easy enough for me to add an additional item because all I have to do is just create the pointers and readjust the pointers. Now again, it's much easier to add something to a singly linked list because all I have to do is just add one node and one pointer, and I don't have to reorder any pointers. So once you add a circular linked list, it gets a little bit more complicated because now this pointer has to change to point to the next one, not the first one, and then I gotta make sure the next one points to the first one. And if I do a circular list, if I'm doing a doubly linked list, then I have to make sure that like this one updates the point to the new last one, and etc. So like basically, while circular makes things easier in practice once you actually have the data structure created, and having it doubly linked is nice because again it makes things easier once it's created. Creating it's much more work because you have to plan for all these different things that have to move around every time you add an additional piece of data. So just so you can understand sort of conceptually like what's going on here. A couple other terms to think about are the terms bound and unbound. So the question is like, do you have to, if it's bound, that means you actually have to say like how many spots are on my linked list from the get-go. Okay, so basically you might say, hey, this linked list has a maximum size of 5, so that would be a bound. You know, arrays are just naturally bound. You could say it's a bound linked list. And the benefit of that is you can allocate the memory ahead of time, and maybe those nodes can be closer to each other in memory, and you might get a little bit more benefit out of that. Then there's unbound, which is kind of like, I would imagine is more the reason you have a linked list, because the big issue with an array is that you're limited. You have to specify the size right away. But an unbound just means you can always just add another node. You just make sure you create the pointers. But again, the big trade-off here is like, see, I'm taking up a lot more memory because I also have to use up memory for all these pointers instead of just having the sequential blocks that I had before. So that's the theoretical concept of like arrays and linked lists. Now let's just talk a little bit about implementing them. Okay, so I'm going to create a new thing here. We'll call this a linked list, and I'm just going to create a doubly linked list. But I think you see this conceptually should be pretty reasonable to see how the other ones work. Okay, and I'm going to want to make sure that I bring in my node. So I want to import node. So const node equals require /node. And then we're going to create a class called linked lists. Okay. And essentially, let me think about how I want to implement this. Okay. Really what I want to do is I want to extend the node class. So first I want to do is like LL node. So we'll say class LL node extends node. And just remember, like, nodes have data. Okay, so in the constructor we have data. Cool. Let me go back to my linked list. But now I want it to have also additionally like a previous and next property. Okay, so this. So we're gonna say previous. It starts off as null. And next equals null. Do them as private properties. We're gonna have to use methods to use these things, and then we're gonna have a constructor, and the constructor will take the previous node. Okay, the previous node, and we'll take the piece of data. Okay, first thing we want to do is call the parent constructor to pass in the data. So super data. Okay. And then what we want to do is we want to say like this dot previous equals previous. So that's the previous node. And then we need to create a method to set the next. Okay, so set next, and we'll pass in sort of the next node. And what this will do is we'll take this, and what does it just takes this next and say equals whatever you passed in as next. Because basically what you're doing is you're going to take the previous node and use its set next method to set this new node as the next node. So that way it knows that it's the next one. Cool. Okie dokie. Cool. Then basically what I want to do is have a method called getNext that just returns this dot next, and then get previous that returns the previous node. Okay, and again, so basically the idea here is that each node is going to have a point, it's going to know what the next node is and what the previous node is. All this linked list is going to do is just kind of basically add, kind of maintain sort of traversing these unrelated nodes, or these nodes that are only like shallowly related. Okay, so now that we have that set up, okay, then this is going to have a property called current. So he's going to just know what his current node is. And then we're going to have a constructor. And in the constructor, you pass in the initial piece of data. Okay, the initial piece of data. And the initial piece of data will be inside of a node, constructor, or I mean current, equals, and it's this dot current. This dot current equals new LL node, linked list node, and it's going to be one that's wrapped in, has no prior, and will, that's going to run into an error because it's going to try to use, think about that. Let's just make a ternary operator on this. If this dot previous, so that way if it's null, it won't do this. It just won't do nothing. There we go. So that way that doesn't cause an error every time we do that. So when creating the initial list, there is no prior, and I'm not going to make this circular. I'm just going to make this, you can go forward, you can go forwards and backwards. So this is a doubly linked list, but not circular. Keep it simple. Okay, node, and then it's going to take the data as the data. Okay, nice. So now what we want to be able to do is I want to be able to add a node. Okay, so I'll say I want to add data, so I'll say add data. Okay, and what this is going to do, okay, it's got to kind of basically what it's going to do is, let me think about how I want to do this. I want to basically keep going down the list until I find the one that has a null. That has a null next. Okay. So add data. So we'll do while let's make this, probably recursion might be the better route. So const next equals this current dot get next. If next, so if next is null, if it's something, then it's gonna turn this dot next. Yeah. Yeah. So basically, if or we're just gonna have to do is through a nested loop instead, actually. So while true, const next equals this dot current dot get next. If next, so if next does have a value, no, this still doesn't work because it's going to keep calling the same next. Or we could do this. Let's do this. Let's make another one that's just called last. So that way you always have the last node accessible for adding. Okay, last. Okay, and in this case, this dot last equals this dot current to begin with. So your current node is kind of like the information you currently have available. Okay. And then let me just remember what I called it on the node. I think I may have a method to get the data. Yeah, get data. Okay, let's see here. Back to my linked list. So current will be my current one. Last, and then last will be my current one. And then we want to get the data of our current one. So get data would just be get data. All it would do is just return this dot current dot get data. Okay. And then if we want to add, we've taken some data. And what we do is, let me just remember how we did next. Set next. Okay. So then what we do is we take this dot. Well, first we create the new node, const new equals, or new node equals a new LL node. And then we have to pass it the previous, which would be currently this dot last. And then the new piece of data. And then this dot last, we're going to set its next. So dot set next, which will be the new node. And then the new node, this dot last, will then become the new node. Okie dokie. Cool. And then we just need the traverse. So basically next, we'll always just say this dot current is always going to be dot get next, or equals this dot current dot get next. And then back this dot current get previous. So that way it just keeps alternating, like the current equals this, current equals that. But again, each node has kind of got the references to each other. And I think this should do it. Okay, that should be our linked list. So I just need to export our linked list, module dot exports linked lists. Oh wait, that's not how that works. Equals. Then I go to my Scratch, and I'm going to now bring in the linked list. Const linked list equals require dot slash linked list. So I'm going to say const LL equals new linked list, and we're going to say our initial data is 1. Okay, and then we're going to say LL dot, let's add another piece of data. Let's add 2. LL dot add 3. And now let's traverse our linked list. So if I do linked list do get data, I should get 1. So this should be 1. Then we'll go to the next spot. So next. Then I should do get data again. That should be 2. Then I should get 3. And then it should be LL dot back. I should be able to go back, get the data again, and now I should get 2. And if I do it again, I should get back to 1. So I should be like 1, 2, 3, 2, 1. That should be the output. I'm not feeling 100% comfortable that I nailed that, but let's find out. Node scratch.js. Yep, I figured there'd be an error. Cannot read proper to get data of null. Okay, and what point was this? No, I didn't console log any of this, so I don't even know when that happened. So let's try this. Let's do console.log against all of these. Control C. 1, 2, 3. Do 1. Let's see how far I got. So we got 1. So the first time I did the get data, I did get 1. Then I went to 3. So let's take a look. Let's examine. Okay, so when you do add next, we are adding creating a new node. The new node. This outlast is the previous. And then data is the date of the node. And then we take the new node and set that as the next of last, or the current last. And then, oh, that's why. This dot last. There we go. Let's try this again. And there it works. 1, 2, 3, 2, 1. Okay. So I had it. I just had a typo. Yeah. So because that all makes sense, that I'd be able to traverse the list up and down. So there you have a linked list. Okay. So basically, again, each node is aware of each other. So each node has 3 pieces. It's the data and the next and the previous. And then the linked list is just basically traversing all these interrelated nodes and just looking at its current node and using its pointers to jump between all the related nodes. And then that's essentially what a linked list is. Okay. And the cool thing is I can just constantly add to it. So if I were in like C, I wouldn't necessarily have to be not bounded by the same constraints that an array in C has, where basically, hey, I have to make sure I say 5. The only issue is I can't quite as easily say, I mean, you could try to program it to work like an array where I can say, hey, go to 2, and then I would have to like go back to the first node. But here's the thing, my linked list only knows what node it's currently on, at least the way I implemented it here. So it knows where the next node is, and it knows where the previous node is, but it doesn't know where this whole list starts, and it doesn't necessarily know, well, I did keep track of where it ends, but that's not necessarily always the case either, depending on how you implement it. So that's linked list. I think we kind of went through that pretty thoroughly. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.